So today we're going to be talking about approximating areas. So by that, I mean the area between the curve y equals f of x, I just sort of emphasized right there, and the x-axis. There is also a way of doing this between a curve g of y and the y-axis, but we're not going to talk about that today. It's very similar though. So you can see it's not a pretty standard shape, but we can sort of deal with that by saying like, oh, let's do this by approximating with a shape that we do know, and that is by rectangles. Now, what we can do is there's different ways of doing it. We can say like, oh, I want to divide this into two parts. And then we know that it's going to be we can take this as two rectangles. Now, as you can see, that's not so good. So the whole area is that green A, but I can also approximate it using two other rectangles, area 1 and area 2, and just add those up together in the end. But it's not a very good approximation. You can see all of this extra space that I have in there. So how can I make it a better space? Well, I can do it better. More rectangles, because the rectangles will fit better underneath that curve. So if I do that, and let me just choose a different color, let me choose red, just because. And you can see when I draw in 4 red rectangles, that it's going to be a better approximation than what I did. Now, when I add all these up, is the sum of this type of approximation is called a Riemann sum when it's added up. So in this particular case, what we have is the sum using that summation notation. So that's what that giant capital sigma means. We have 4 rectangles, so I write it down. Oops, little error. I want to do it using I from 1 to 4. And remember, I is called the index. That's why I decided to use I instead of N. And how do I find the area of a rectangle? It's going to be the width times the height or the length. In this particular case, it looks like it's a height. In each particular case, I equals 1 to 4. The width is going to be whatever this width is going to be. And the height, well, that's going to be the function value. So the function value, I'm going to call it xi star. Some people don't like to use that notation. This just means like any point in interval I. So we tend to have a preference. And if you think about it, this is the x-axis. So a little change in A is called delta x. A little change in x, I'm sorry, is delta x. So in this particular case, usually we want to split delta x into four equal parts. I'm not going to give you the formulas here because it can vary depending upon the exact situation. So what I drew here first that you might recognize is I drew this particular one uses left endpoints. So sometimes it's called the left Riemann sum if it's adding up these 4. There are other choices. There's the right endpoints and there's the midpoint rule. And the right endpoints kind of make sense. It's whatever is the rightmost endpoint of the interval, you sort of take this height instead of the one on the left side that we had up at this top. Midpoint is kind of makes sense. I've made little blue dashes that sort of say to show you that in each particular case, it's sort of halfway between the left and the right midpoint rule to figure this one out. And this is sort of our point of departure. There's a lot of things that you can do. I gave an example with 4 endpoints. So if you have more again, the big emphasis, more rectangles, the better the approximation. It's better approximation. One other thing to take into account is how you will see this asked for. So exact area in this case is done by a symbol you might have seen when we did antiderivatives, and that is this sort of modified S it looks like. It kind of looks like something that you might see on a violin or some other string instrument. And we're going from A is the smallest value, B is the biggest value. The function is f of x. We say dx. That's going to be the exact value. The approximate value, you notice this is the integral, it's sometimes called. So that's what the integral. When we go on to definite integrals, we'll see this more often, but for now it's just a notation thing. When you say you're going to approximate this, you approximate it with a Riemann sum. And that Riemann sum for right now, we know has n subintervals or n rectangles. So it doesn't have to go like 1 to 4 that we have here.